What is up, guys? Jonathan Criswell here, and I'm back with another video. Now, what I have here is my redstone calculator I built about a month ago. I was working on it a little bit earlier, and I got it enough to where it's satisfactory for me. Now, what I'm going to demonstrate is the three programs that it is able to do: addition, subtraction, and the Fibonacci. Now, you will see that it has a button for multiplication and division. However, those are not operational on this, just because I still have to put in that system, and that system would most likely include RAM or a couple more registers. However, because of how the ALU is in this system, it is not. I'd have to redo the whole entire ALU, rip it out, and put it back with a different ALU. But I will show you guys that towards the end of the clip. Now, this computer took me I say computer when really it's just a calculator that adds and subtracts with the counting program. So I'm just going to call it a calculator from here on. If I call it a computer, I apologize. Now, this calculator took me about 7 days to build. It took me about 3 days to build all the actual calculation parts. So basically the BCD to binary, and then the ALU, and then it took me another 3.5 to 4 days to then do the binary to BCD to 7-segment display. The whole binary to BCD to 7-segment display is probably bigger than all of the circuits, all the rest of the circuits in this calculator. But I loved building this thing. I spent about, I want to say, 2 hours bug fixing, which was basically just adding in repeaters where there needed to be, or adding in a piece of redstone that I forgot to place. Normally it applied with, actually, when I say normally, Oh, I'm still recording. I thought it stopped recording. My bad. Okay, anyways. When I said normally, I mean it did all apply with the GPU. And what I'm considering the GPU on this is the binary to BCD to 7-segment. And that was... like, I would go show some of my friends how it worked and everything. I demonstrated, then I just so happened to choose the one number where it was missing a repeater, and it's just like, wait, why isn't this working? So it's just like, okay, well, I guess it's broken right now. So but after they leave, I realized that all it was missing was a single repeater. And it's just like, wow, of course. The one time I got to show people. Anyways, it should be 100% bug fixed for right now. Now, I'm thinking about adding in, or not adding in, either I'm stuck between two decisions. Either A, just rebuilding a whole 10-bit calculator with the multiplication and division circuit in it, or B, ripping out the ALU on this, putting a new one in, and depending on how big it is, throwing in ROM, because this calculator has no ROM, no ROM. It has no RAM at all. Not a single bit of RAM. All it uses to remember numbers are registers. And basically, I'm very happy that I got this working without any RAM. Now, as far as adding in more programs, like let's say I wanted to add in more than just the basic operations and a couple accounting programs, because yeah, let's face it, everyone builds these types of calculators. Now, if I were to do that, I'd basically have to redo or add in RAM. Why did I say redo? I'm sorry. I just need to apologize right now for this terrible commentary. I probably butchered that word, but I don't care. I am terrible with words. If we were speaking binary, I'd be able to do that a whole lot better, but I'm pretty sure a lot of people are not fluent in the language of binary, as far as being able to just say a bunch of ones and zeros really fast and have them translate to letters. But yeah. And now I forgot what I was talking about. Oh yeah, duh. Adding in RAM for more than just the basic programs and counting programs. I'm thinking about doing that, however, I might, if I can figure out how the square root works with Minecraft, then I'll throw that in. But it's like, I want a design that is very compact. Not like, I don't care how slow it is. I want a compact version, because doing all of this on the PC, yeah, that's great and all, but that's the PC. This is console. I don't want to spend like 3 days just building one circuit just so it can do something. I want to spend maybe 6 hours at the most building one circuit to do one thing. Like, if this was on the PC, that'd be totally different. I wouldn't care how big it is. In fact, I'd be worrying about speed, but it's just like, since this is console and I don't have access to Minecraft edit, copy, paste, I don't want to spend hours on end just doing the same exact thing over and over. Like, I get bored when it comes to repetitive stuff. And we are getting to the part to where I show you all the guts of this thing. I believe in about 2 more minutes, I will be showing all the wiring of this. But yeah, what it is displaying now is the Fibonacci program, which I don't know why I just have it set up or labeled as counting program, but yeah, I should label it as Fibonacci just in case I come back to it. But this calculator was built on my redstone test world, and that was a bad idea. because now every time it has to load or unload, it lags the world. Like, it doesn't lag it that bad, it's just like a lag spike. But I don't know, I probably should have built it further away if it was going to be on my redstone test world. But this program was ridiculously annoying to get working with the BCD, or not the BCD, the binary to BCD decoder. Reason being is I used Neuromass. I can't say this name. Neuromaster's design, I believe. Yeah, I think that's how you pronounce it. I'm sorry if I pronounced your name wrong, and if you ever watch this video, I apologize for that. But yeah, I used his design for the compact BCD decoder. Or, yeah, BCD. I keep on saying BCD. Binary to BCD decoder. And getting that to work with the Fibonacci program was ridiculously annoying to set up. Now, the Fibonacci program is in RAM, just because for me to get it to work with the ALU, I'd have to redesign the ALU. So yeah, I kind of took the easy way of that. But yeah, this is how big it is right now. If I redid the ALU and added in RAM, it would be a whole lot easier. And this is where I realized, oh hey, it's nighttime, I should record when it's day so you guys can see it better. So yeah, I apologize for always recording at nighttime. It's just makes it easier for me to work with redstone when the date or when the time is set to night. But yeah, as you can see, this is a ridiculously big GPU. It is very compact for what it does, but it is bigger than everything else in it combined. Now, this is how big the ALU is in this. From that line to this line. As you can see, it is ridiculously long. And all it does is addition, subtraction, and go into the negatives. That's all it does. That's all this ALU is capable of, and it is ridiculously big. Yet again, though, I built this a month ago, and I did not quite understand the ALU designs, or what a ALU did, and what its capabilities are. And the program actually finished while we were looking at that. But we are coming near the end of the video, so I hope you enjoyed it. So have a great rest of your day, guys.